You can put this. Here's the current manager. So hours, again a class-based data. This is in dollars, I guess. You can keep that also. Monthly income, a lot of numerical aspect. Monthly rate also. This would be more or less similar to each other. Okay, not getting into more of that, I'll just do an execute. Okay, and I get this data. So would quickly help you to understand how the distribution of the numerical data is, right? Okay, so not spending more time over here, what I would be doing is I would be going ahead and I would now come back to my, so there is a possibility that you can do a lot of transformations over here, right? I would leave that exploration with you. I'll jump into model. Now I want to do a logistic regression model, so obviously that is form of a linear model, and over here by default the numeric is deactivated because it's a class-based data. You cannot do a linear regression over here. You have a logistic and you have a probit model. In your sessions you would have already done logistic regression and you have that concepts in your in your brain. So I would be using the logistic regression model, and I can quickly say and execute. So here it builds up your logistic regression model, and this is how your model has come, right? You have the ANOVA table, you have everything you need which you typically would have had over there, right? You can go through this. Okay, now comes the evaluation part, right? Now what we can do right now is I want to check the evaluation on the training data also, and maybe I want to do it and I'm not interested maybe in the probability. You can have the probability or you can go for the class, right? So let's say we keep the probability, and what do you want? You want to look at the ROC curve, you want to look at the precision, you want the sensitivity, you want the score. There are so many things, risk, cost curve, lift, right? So let's say I want to look at the ROC. Okay, so what I would do is I would basically do this, and I will just say and execute. It would need a package called as install ROCR, and say a yes to this. One time install again, as we have discussed before also. So here you see an ROC curve and the area under the curve is 0.87, which means it's a good classifier, right? Now obviously when you were doing this in the code based approach, it was a long process. Here it's very short, very quick to understand, right? Okay, now let's say we want to actually do, say, the precision, right? We can do that as well, precision charts. So you get the precision charts, how the model is working, the recall, right? Now obviously you will have to remember what is precision, with what is recall, what is sensitivity, what is specificity. Obviously that's already done in your theoretical sessions, data science using R or data science using Python or the complete IDS modules. So I'll just quickly show you how to draw the sensitivity chart as well. So you have so many things, right? So you just go back over here, you have all these charting options, very quickly done. What we can obviously see is your model is doing good, right? So now say for example you want to do the score the data and save it to a file. That's where you will do it. So you just click over here, right? So what do you want in that? You want probability or you want a class of the model, right? So let's say we want the class, the final class to be marked. You can have the probability as well, right? So say we want the class, we want identifiers, or we want all the data. Let's say for now I just want the identifiers, right? And I want the training data to be used over here. So I'll just say and execute. Obviously it will ask me for a file name. So what I will do is I'll just rename it to something sensible. So I'm saying prediction on train data. Okay, and where am I saving this? I'm saving this on the desktop, and I'll say save. Obviously it is going to use 1470 observation. It has already used 1470 observation to build the model, and then now it is going to classify it on the same data. And I'm not keeping all the data points, that is all the variables. I'm just keeping the variable of my interest, that is the dependent variable, versus the prediction against that dependent variable. I have not selected probabilities, otherwise it would have given me the probabilities. I'm just selecting it as class, so I'll get the final classification. Okay. In the meanwhile, I want to do a test. Okay. Now I want to do the test on the same data set. Now one option is I call the other data set as well. So let's do that. So I say import data set again, because it is from Excel. I will have to go through this only. Say browse, go on the desktop. This is the data. Say open, and I want the holdout data set, that is the testing data set. Okay, and I'll say import. Let me just change the name as holdout. Okay, and say import, so that both the data sets are kept therein, so I don't lose this data also, and I can access this data also. Now go back to your data tab, and now if you click over here, just to, okay, there's a refresh problem, so I just selected something else and came back again, so that this is refreshed. Now I have the holdout data also. Now another option is that I want to do so if you look over here, this is the R data set. I don't need to bring the data in again for evaluation. I can go over here, and instead of the training data set, I can do it on the R data set, wherein I have the holdout data set, which is directly coming from here. So I can apply this on the holdout data set also, only on the identifiers, and I can say execute. Okay, so I'm keeping this as it is, and I'm saying it as desktop, and I'm saying save. Okay, so now I'm going to minimize this, and I'm just going to see my predictions for the train. Right, so this is how the classification has happened. This is the actual attrition basis the actual data, and this is what we have got as a prediction. Right, so if I just use Excel and I just do an insert and I do a pivot table over here, okay, and I just bring the attrition GLMs, right, so this is kind of a classification attribute, right? So you can get the misclassification. This is the attrition no, and this is the GLM no, right? So this is the correct no classification, this is the correct yes, this is the wrong no classification. So the data actually says it's a no attrition, but your model is saying yes, this employee is separating. This is where it says that the data says yes, the person is resigning, has resigned, whereas your model says it's a no, and this is again a correct classification. So you can see that this number is quite high, so overall the model is doing good, right? So this is how it's working for you. I'm going a bit quick over here because you have anyway done all these things in the basic part. Okay, going back to your R studio. Okay, now yeah, we remember we had the other also, the holdout data set. You can check in the holdout data set as well, right? So this is for the holdout data set how the classification has worked, right? So here it doesn't seem to be that great, right? So see, for example, in most of the cases we are having no. So let's do a pivot over here also. The rows are the attrition, this is the prediction. Just putting the values over here. Okay, so the no 165, the misclassification is 18.4. So if I look at the correct classification rate, it would be 165 plus 13 divided by 200. Okay, so 0.89 is the, you can say, the accuracy. Okay, so doing good, not a problem. Okay, so that's how it is working for you. I'm just going to delete this, not required. Okay, here comes my RStudio. So that is how you would do a logistic regression model using your data miner. Okay, if you want all the columns, you could have done this, which is all, right? Also remember one thing, when I showed you the data import, right? So for this to work, right, when you do it for the first time, since I already had it in my environment, it didn't give me an error, right? As I had installed it before that, right? For you to work, you would need one more package. It will not prompt that you need to install it. When you do this, right, when you import using our data, click over here and say execute, you won't see anything happening, or it will fail or something like that will happen. In that case, you will have to import that manually, right? So I'll just show you in the history how I did it. So let's go back. I'll just tell you the name of that package. If it's over here, okay, yeah, this is the one. So you need to install this bit ops. You have to keep dependencies is equal to true, right? That is where you would be able to import the sheet wise data. Okay, so just make sure that this package is installed, bit ops. Okay, and then it should work fine for you. In the meanwhile, if you want to do a little bit of more evaluation, you can look at all these other options also. You can have the risk curve, cost curves, right, precision, sensitivity, and so on, right? Now if I want to do something like the data, right, so say I want to create a model on this, but I want to create a partition. Now let me create the partition. So I'm going to create the training data, the testing data, and the validation data, right? Now if you want to do this, you can do this as well. I can change the proportions manually also, so I can keep this as maybe 20 if wanted. That's a choice, and then I can make this as 10. It's all up to you. And then I can say execute. Yes, I want to overwrite. Come on the model again, select the linear, logistic, execute. Model is built. Okay, and now when I come on evaluate, okay, say for example I have to do, now you would see that these other data sets are also activated. If you remember, prior to this, validation, testing, and full were not active, only the training was active, and we used to separate our data set, right, from our environment. We pulled out holdout data set using our data set, right? Whereas in this case, this has become activated because you have created these data sets. Okay, so you have all of this in 3 partitions. Okay, so we can do a validation dataset testing, or the testing dataset testing, or you can do it on the same data as well. So you can have an ROC curve created for training, validation, testing, or you can do it on the full model. Let's do it for the validation, and let's say you want to check the class. Then execute. So you got an area under the curve as 0.85, right? Now say you want to do it on the training data set. Just say execute. 0.88. So on the training data set, the area under the curve is higher. On the validation, it is a bit lower, 0.85. Now this is expected. And if you go on the testing, it is 0.8, right? If you want to do on the overall, you have to say full. Now it will use all the data in this case, training plus validation plus testing, right? And if you want to do it on a separate CSV, you have to bring the CSV file. If you want to do it on the R data set, which is obviously in your memory over here. You will have to pull out this data and you have to apply this. So this is how you would be doing a logistic regression model. You have the logs which are created anyway, as I had told you before also. All of that will be over here.